Okay, science time. Today we're talking about, let's call this dating and the fossil record. Some people, not me, some people's ears perked up when they hear about dating. Taylor? Yeah. What do I mean by dating? I'm not talking about an 8th grader going and buying Arby's #1 for their girlfriend. Like, that's romantic. That's romantic for an 8th grader, you know. Hey, you want to go out with me? Let's go to Arby's. Let's have my mom drive us to Arby's. Mom, wait in the car. Anyway, that's not the kind of dating I'm talking about. What kind of dating am I talking about here? Yeah, dating means telling the age of, I'm going to put an earth material, because really we do this, I'm going to spell earth correctly. We do this with a lot more than just fossils. Give me examples of earth materials. I want 3 examples. Dirt. Let's put sediments because it's a little bit more scientific. Sediments, fossils, what's another one? Yeah, I would call that fossils. Hunter had said organic life. I would call that fossils too, probably, because if we're dating it, and it's probably fossils.
Do fossils still have DNA?
The question was, do fossils still have DNA? Not usually. DNA has a half-life, which is different from, we'll talk about radioactive half-life, but DNA, even if it's preserved, or if it's, you know, part of something that is preserved, it decays over time just as a chemical compound. And so no, I think the half-life of DNA, you can look this up, and I could totally be wrong, but I think the half-life of DNA is something like 15,000 years. And so then after even only 50,000 years, the DNA is completely different from how it was at the beginning, unusable.
Even like in the amber and stuff?
Yep, the question was even in amber. Even if the thing is preserved on a macro scale, the compounds that make it up, the DNA especially, is non-stable and it decays. Fate, what was your question?
Rare earth elements.
Okay. So another example of a earth material, we could put elements here. I'll just put elements because I kind of ran out of room for what you said, but that's good. Gabe.
So does that mean Jurassic Park is just a bunch
Jurassic
of
Park is a bunch of bogus. Jurassic Park is fiction. That's another word for a bunch of bogus, but yeah, fiction. Okay, so dating is telling the age of an earth material. Just FYI, Gabe, they got around that in Jurassic Park by saying that they also used DNA from frogs, like they combined them both somehow, which is not a real thing that can happen, or at least as far as I know it's not. But that's how they got around in Jurassic Park, because otherwise they would have had someone be like, oh, excuse me, DNA half-life, and they'd be like, oh, frog DNA, actually. So I don't think that's a good counter-argument, but whatever. Anyway, so today we're talking about dating, telling the age of an earth material, and we're going to focus first on this one, on fossil. So first let's define a fossil. We know a fossil has to be how old? We had talked about this before. Fossils must be, they are the remains. We had this as part of our bell work. I'm just going to tell you because it was a part of our bell work in order to prepare for this. So the remains of an organism, I'm going to put preserved remains of an organism greater than 10,000 years old. Another way of writing 10,000 years old is lowercase k, capital A. This, we're going to use this a lot, so I want you to write this down. Ka, like this, lowercase k, capital A stands for kilo annum, which means 1,000 years. So if I have 10 Ka, 10 kilo annum, that's how many years? 10,000 years. There are other abbreviations we use this for. We have also mega annum. Can you guess how many that might be? 1,000,000 years. 1,000,000 years. And then there's another one called giga annum, which is 1,000,000,000 years.
So like gigabytes?
Shh. Yeah, so not quite. The question was, is a gigabyte 1,000,000,000 bytes? A kilobyte is defined as 1,024 bytes because it's in a base 2 system, and 1,024 is 2 to the 6th, 7th, some power, 2 to the 10th power maybe. So it's not quite a billion, but it's 1,024 times 1,024. That's what a giga is. But it's roughly a billion. It's probably like 1,000,000,000 some number of million, but that's a gigabyte. Anyway, gigaonum is exactly 1 billion years. And these have abbreviations. Kiloonum, as I said, is lowercase k, capital A. Megaonum is capital M, capital A. And gigaonum is capital G, capital A. We use these in science instead of saying, you've probably seen in like a elementary school textbook or in a nonfiction dinosaur book, you probably see something like BYA for billion years ago. We don't really use that in geology. We use capital G, capital A, gigaonum, okay? You need to know these. You need to know these, yeah. Geology, paleontology is a section of geology. Paleontology is also a section of biology. It's a kind of, biology is an intersection between geology, the study of planet Earth, and biology, the study of life, and in the middle is paleontology. Or one thing in the middle is paleontology. Okay, so that all aside. Do you have questions about this? Why do you think we use onum? That be? Yeah, it's related to the word annual. You know, when we use AD, like this is the year 2020 AD, that stands for Anno Domini, which means year of our Lord. It isn't. Anno is the Latin word for year. Annum means it's an adjective version of that. So if we use megaonum is million years, gigaonum is billion years, kiloonum is 1,000 years. Questions about any of that? You need to know those, okay? Yes, Hunter.
Time before Jesus was born,
Yeah.
what did they say for time? Because they didn't say before Christ. They didn't-
Right. There were several. This is not what this is about. That's more of a social science question, but that's fine. There were lots of different ways of reckoning time. In fact, the way we agree upon thinking about time, like on our daily life, this was thought up in, like, I would guess, like the 1850s. I don't actually know, but this came along a lot later. But even the way we think about our daily life, the time that goes by, the years that go by, there were several different calendars, and this wasn't agreed upon until like the 14th century, and maybe even later than that for some countries. And so before that, like ancient cultures that we would say are in BC or BCE, if we're trying to be politically correct, time, they would have completely different ways of thinking about time. And for the most part, it didn't matter. Like the only people that it mattered to were like scribes, like people whose job it was to record history, and they just did it however they want. And now when archaeologists, people who study human remains and human civilizations, when those people find documents that say that, they have to like kind of think about, well, the Sumerians measured time this way, and so we know that this document means blah, 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 blah. They wouldn't have used BC, obviously. Okay, so anyway, other questions about this? Thank you. Good questions. Fossil. There are lots of different ways a fossil can form. Here's a fun thought experiment. I do this every year. You know about coyote? Yeah. You guys call them coyotes because you're from the Wild West. You know about a coyote? What if there's a coyote running across the football field? What is your temptation if you're a ranch boy? You won't shoot it. What happens? Okay, you do it. You do it. The coyote's running across there. Dalton shoots it with a 30-06. He blows its legs off. Whatever. The thing is dead in the football field. And then for whatever reason, no one picks it up. Also doesn't do anything with the field. We just leave it there, and it's dead.
Sioux County, basically.
It's dead. It's just like being in Sioux County. Just wild dogs, coyote, everything, just dead stuff in the middle of the road. Okay, but we just leave it there. If we left then and we come back a year later, what will there be? Raise your hand if you know. I want to hear a couple of different answers. Dalton, what will be left?
There will be like bones.
He says bones. What do you say, Will?
A carcass.
A carcass, he says. Any other ideas? Fate?
Bones, teeth.
Bones, teeth. Who else? 1 year. 1 year. Not next week. 1 year. Taylor?
It's
Skin? Skin will be ripped up.
Flies and maggots.
You think there'll be flies and maggots in a year from now on the dead body?
Yeah, it's still fresh.
Kimber, what do you think? What do you think, Ty?
After a year.
Okay, let's take a vote. This is not something we're voting on. There is a truth to this, but let's vote. Okay, if you think there will be, yes, okay, there, Ty, that's exactly what I'm getting at. But if you think there will be flesh left on it, raise your hand. Okay, there's still going to be flesh, he says. If you think there's still going to be, if you still no, listen. Okay, if you think there will still be bones left, raise your hand. Okay, now keep them up. If you think there will also be teeth left, put your hand up or keep your hand up.
Unless this guy drinks a lot of Coca-Cola.
Okay, the answer is probably, most likely, in all I've seen this happen because there was a dead deer on the place where I walk my dog. The deer died actually, it was more like a year and a half ago. But do you know what's left of it? Nope. Nothing. Absolutely nothing. Not one thing. The flesh has been, no they didn't. The flesh has been consumed by scavengers probably, almost instantly. I think a week later we'd come back and we would see it as a pile of bones. Certainly a month later we would come back and it would just be a pile of bones. What happens with the bones? Eventually they what? Yeah, they usually don't get buried. They usually just, in fact, something kind of interesting, animals will come and consume bones. Animals eat calcium just like you do, and a little squirrel does not drink its mother's milk or any kind of milk. And so when woodland critters need calcium, they eat bones. A deer will eat bones. Yeah, there will be almost certainly, I would say 95% of the time, there will be nothing left a year later. Certainly 10 years later, there will be nothing left. In a fraction of cases, maybe it is very, I'm going to write this, it is very rare for remains to be preserved. Shh.
I have a question.
Shh. Remains to be preserved even 10 years later. So what must happen? How are there fossils, which we know there are fossils that are 3 billion years old. How are there ever fossils? If in all likelihood that coyote, dead in the middle of the football field, is gone forever, nothing left, not even dust left after only 10 years, how is it that there could ever be a fossil that's almost 3 billion years old? What do you think, Fate? What do you think, Fate?
It was quickly buried.
There you go. Okay. Rapid burial. This is the key. Rapid burial. It doesn't always have to be, but it usually involves rapid burial. Why rapid? Why rapid? Give me a second, Hunter. Why rapid? Why does it have to be fast? Hunter?
Because it's the ground takes like weeks to shift over it. It's already
Exactly right. The decomposition will happen before the burial if the burial's not rapid. So why is the burial important?
to like preserve that body and make other organisms.
Yeah, we'll talk more specifically, but the burial makes it, just as Hunter said, the first thing it does is makes it so large organisms, scavengers, can't access their remains. That's what burial primarily does. But then there's going to be another thing that occurs here in a second when we talk about specific types of fossils that makes it so that the fossil is still visible after not just 10 years, but millions or billions of years. Fate, you had a question?
Also, so that more layers are added, it's pressurized.
Exactly. And then when more layers are added on top, the remains can get pressurized, which can cause chemical and physical reactions that can make it into a fossil instead of a bone. Yes, and we're going to talk about it in a second.
Fossils that are 3 billion years old are like probably most likely like caved in by something like catastrophic, like a volcano.
Yeah, the fossils that are that old, I think maybe the oldest fossils, I can't remember specifically, but I think around 3 billion years old are the oldest fossils. And first of all, they're all single-celled, because that's the only kind of life there was single-celled life. But also, they have to be changed. That thing itself is gone forever. But what's left is an imprint, and we're going to talk about that now. Taylor, you have a question.
I just need to clear my confusion. So, did we start counting like, it's 2020, what is it, 3, 2? In 2022 right now, did we start counting years after Christ died, or how, what?
Yeah, so this year, 2022, is 2022 years after Jesus Christ died. Yes, that's the correct thing.
So you're telling me that man was 3 billion years old before he was born?
I don't think this is not the realm of this class. Obviously, That's a theological question, Taylor, and we're going to talk some more about that at a later date. I do want to address that. Not that question, because that kind of came out of left field for me. I would say that man was certainly not. That man was 33 years old when he died. But if you're talking about, this is a theological question, not a science question, but if you're talking about God, the agreed upon thing in Christian theology is that the Lord is older than that, certainly. Yes, Will.
So, if scientists don't agree with the Bible, like that we came from monkeys, why do they use before Christ?
That-
And stuff like that?
That's a question we are going to talk about. That's one thing I want to address after a while, but not right now. the agreed upon, it happened that the way this class has come to be about how we got the calendar, which is fine. I don't mind telling you guys about the calendar we have now, but it was agreed that we would use the death of Christ as a benchmark when kind of the Catholic Church was in charge of not just church matters, but political and scientific matters as well. And it was agreed upon that's the date we would use. And then when people, as you say, kept using that, eventually most scientists use this, or I should say anthropologists use BCE, which stands for before common era. It means the same thing as BC, before Christ, but it stands for a different thing. And then they use CE for common era instead of AD, which stands for Anno Domini. And I'm sure there are political and social reasons for that, but we're not going to get into that because that's not what we're really worried about. And furthermore, that's not the calendar we're using here. We're going to talk about what we call a geologic timescale, which is much more important for this than our actual calendar, which involves like February and 2022 and things like that. So the second thing we're going to talk about, we talk about fossils, and you have to understand that most of the time an organism that is dead will be gone forever after a very short amount of time. But there are several ways that a fossil can be preserved. Fossil preservation. Let's talk about that. Fossil preservation. The first way, I would say this is the rarest way, is soft parts. Original soft parts. You guys got some soft parts? What's a soft part you have as an organism? Skin. Armpit hair? Yep. What else? What else? What else? Cartilage. Yep. What else is soft parts? Please stop getting distracted. What else is soft parts? Gums. Yeah, what else?
My nose.
Tissues, organs, nose. Yeah, all those things are soft parts. Original soft parts is very rare. And this just means that original here, original means that it was actually literally part of that organism. So in our coyote example, the coyote has died. Let's say that this time it got buried. And then somehow, by a miracle, we come back a million years later, we come back a million years later and dig it up, and there's still an eyeball intact. And it's extremely rare, but it does happen, that the whole eyeball, and maybe not a million years, we call that something else will have had to have happened. Because otherwise, obviously, some worms and bacteria and stuff will eat the eyeball. But if some other stuff happened, like for instance, if it was preserved in amber, you remember I showed you that picture of an amber, a dinosaur tail that was preserved in amber. The feathers are soft parts. And so when we look at this piece of amber and it has the dinosaur tail in it, these feathers count as soft parts. And so original soft parts includes when things are trapped in amber. Do you see how this would be more valuable? Because this organism, at most, is 65 million years old. It's extremely old, but it's really cool that we can find original soft parts with it. This could be very valuable because there was also a little bug in here, and we can tell not just about this bug, but we can tell about the meal that it ate, because that's all preserved in this amber. Do you see what I mean? This is extremely important information, because how else are we ever going to learn what this bug ate, or that dinosaurs had feathers? Because that stuff will be gone forever. It's so dang old. So this is extremely important that we can find this, but it's also extremely rare. What do you think the next one is? If this one was original, what do you think? Original hard parts. What's a hard part that you have? Bones. What else? Teeth. What else? Maybe claws. Fingernails. Yeah. Original hard parts would be So they have to be the literal parts of that organism. This is also rare. When you see, have you been to the Denver Museum of Nature and Science where they have that big Tyrannosaurus Rex? That is not bones. It looks like bones. It looks like bones, but that is not bones. In fact, even when they found it, that is not bones. What it really is a plaster cast that they made so that when people touch it, it doesn't ruin the actual bones. But even when they found it, that was not bones. That was rock. But it was shaped like bones. But the original hard parts is if there's actual bones. Actual stuff that is part of the organism. Yes?
I saw this thing on TikTok.
Are you guys taking notes? Okay, good.
This guy talking about this baby in this museum that's been dead for a long time. Or like, it was still perfectly intact.
Okay, so you're talking about a thing that was preserved as original soft parts. And the thing in this case was a baby. How sad. Okay, the third one is called petrification. And we also sometimes call this, there are differences, but we sometimes call this permineralization. And this is a special type of petrification. But this is the most important one, I would say. These ones can be very important for helping us to build knowledge, like that we now know that dinosaurs had feathers and what this little bug ate for lunch or whatever. But it's very rare. And so the one that's actually probably most important, the most common, is this petrification. And petrification happens when, it's kind of in 2 or 3 parts. I'm going to put in 3 little bubbles here. The petrification happens when a thing dies and is buried, okay? So here's its bone. It's been buried. All the soft parts were consumed by scavengers or decomposers or whatever, and it's left with just a bone, okay? This is somewhat common, especially after only maybe 100 years. If you went to the grave of someone who had been buried properly, and it was a 100-year-old grave, you might find bones. So it's not uncommon for this to happen for a 100-year-old thing, okay? Unlike the example earlier. The difference is that was buried, right? Not just left out in the open. But then what happens is, over time, even this, after 1,000, certainly after 10,000 years, this would be gone forever too, just dust. So what happens is this, what's around this? If it's buried, what's all around this? Rock. Rock, dirt, sediment, some kind of material. What happens as water seeps in here and then evaporates, and then seeps in and evaporates over and over and over again, the bone itself starts to become replaced with rock. So instead of being, all the little holes that the bone has get filled with rock. Okay, so far so good, right? You with me?
Right.
And then after several years, the bone is gone. The bone itself is vanished. It's turned to dust. It decomposes. Everything decays. And so what's left, though, is just the rock, and it's in the shape of what? Bone. It's in the shape of a bone. So when we see the dinosaur at the Museum of Nature and Science in Denver, even when that was found, that's actually a plaster cast so that people's hands don't ruin it. But even when it was found, it was rock. There was no bone left at all. So why is it important? Oh, it's just rock, like the rock around it. Why is this special? Because it's what? It's in the shape of the bone. So we can still see the shape that it was before. And now that it's rock, how long? Well, it depends on the kind of rock. Not forever. Nothing lasts forever. But it could easily last. Rock. There are 4 billion year old rocks on this planet. So the rock can last a lot longer than the bone. So you see why this process is important? The petrification means to make into what? Can you guess? To make into rock. So the thing itself absorbed rock, and then as the thing decayed, the rock is left behind the same shape. Hunter.
Is petrified wood really old?
Yep. Petrified wood can be up to a couple billion years old too, because the same thing has happened. The wood, which decays over time, has got rock in it, and then as the wood decays, the rock is still in the shape of that wood.
Yeah, there's like, have you seen
Shh. And some of those aren't very old, but some of them are extremely old. Fate.
Okay, so if I have petrified wood in my house, do I have to give it to the government?
No, it's an invertebrate, remember? We talked about this. Yes?
But my dad has a lot of petrified wood.
Cool, but you understand what petrified means now, right? It has absorbed sediment, turning into a stone, and then when the thing decays, even the wood decays, the stone is left behind the same shape, okay? Next one, questions about petrification or permineralization? So far you're good on all these methods of fossil preservation, is that right? Yeah. Are there any questions? Fate.
Soft parts can also be preserved by freezing.
Yep, that's right. Soft parts can also be preserved by freezing. There are lots of different individual methods within each of these, but these are the broad ones, okay? So another kind, let's do these two together. This is cast, and 5 is mold. Let's do them the other way around, sorry. A mold exists so for instance, I have this seashell. First of all, this seashell is not 10,000 years old, but say it's 10,001 years old. It isn't, but say it is. What would this count as right here? Is it a fossil? Fossil, yes. What kind? It would be original hard parts if it was just this shell. This shell will not last 10,000 years. It'll decay, it'll decompose, it'll break down. But what can happen, especially with shells, is that a mold can form, which is where if I have a soft material like clay, like I might find at the bottom of a river, and this is pressed into it, the clay then has the shape of the clay then has the shape of the.
It does.
Is anyone even listening to me?
Yes.
Okay, the clay then has the shape of this, but except for instead of being a shell, it's a what of a shell?
It's a mold.
It's a mold of a shell. It's a hole. It's a hole shaped like a shell. It's negative space instead of positive space. And then what can happen is that hole can get filled, like this did, with sediment. And then when the sediment comes out, it's the exact same thing, except now it's made of sediment. Will this last longer or not than the shell itself? Longer. It'll last longer. So the mold is what we call the negative space left behind. You know what I mean by negative space? It's a hole. It's the same shape, except it's a hole instead of an object. And then, when the sediment gets filled in, it forms the same exact shape as the object, except now instead of being an object, it is sediment. Just like this. Why is this one important? Well, because it'll last for a long time, a lot longer than the shell itself will, and it's the exact same shape as the shell. Do you have questions about that? Hunter, what's your question?
Kind of a little bit unrelated, but it's about like preservation.
Yeah.
There was an infant sacrifice kind of in Peru, or it was like I think it was in the Andes,
Mm-hmm.
and it was 2,000 years old, and there's still like things coming.
You're talking about there's a female mummy that they found in the Andes Mountains, and she was, and do you remember how was that object preserved? It had been a girl. Yeah, it was not just the cold, but it was the cold and the, what else helped the original soft parts be preserved? Her bones were there, but so were her tissues. It was the cold and how dry it is. There's almost no rain at all in the Atacama Desert, and so that person was preserved because of how cold and how dry it was. So her skin just, instead of being consumed by bacteria, it's too dry and too cold for there to be bacteria, so it just kind of dried out and shriveled up like jerky. Yeah, it is. We haven't gotten as far as I wanted to today, but we're running out of time. Do you have questions about how fossils can be formed? Okay.